Hey, grade 11. So today we're going to talk about velocity and speed. So we've already mentioned velocity and speed, but we've kind of been looking at it in the terms of average velocity and average speed. But as we start to get a little bit more advanced, we're going to find that average velocity and average speed don't actually give any information regarding to how fast an object is moving at any given moment. So what we're going to talk a little about today is what's called instantaneous velocity and instantaneous speed. And what we can do is we can determine that at any given instant of time. So let's start with a little bit of vocabulary. So what we're going to be focused on today is maybe a concept that you guys have heard of before, but that's uniform motion. So uniform motion is motion in which the velocity of an object remains constant. So what that means is if we have an object, this object is traveling at the same speed throughout its journey. So for example, 5 meters per second to the right, all throughout its journey. So we don't have any point or any change in this object's speed at any point during its travel, so we say that this object is in uniform motion. And with an object that's in uniform motion, the displacement of the object will increase the same amount for each unit of time that passes. So if this, again, 5 meters per second object is traveling, that means every second, 1 second, 2 second, 3 second, 4 second, 5 second. So every second it's traveling, it's going 5 meters, 5 meters, 5 meters, 5 meters, because it's going 5 meters per second. So in constant velocity or uniform motion, the displacement is, we say, proportional to time. So as time increases, the displacement will increase by the same amount. So it's not exponential, it's going to be linear. So since the velocity is constant, like we said, it is unchanging, it also means that the acceleration of this object is 0. So we're going to talk a little bit more about acceleration as we go, but basically acceleration just refers to a change in velocity. And if the velocity is constant, like we mentioned above, then there can't be any acceleration because, well, it's unchanging. So there's no change in the velocity. So before we go into just our topic for today, I just wanted to bring up this, what I call the velocity triangle. I'm just going to try to change color here. So I'm going to bring up this velocity triangle. And what you can use this triangle for is anytime you want to determine any part of either displacement or time or velocity in a given scenario, you can use this triangle to kind of help you out here. Now this graphic I found was a little off because this should say displacement. If we're talking velocity, we need to say displacement. We need to say displacement. So you may or may not have seen this before, but if we want to find velocity, we know velocity is equal to displacement over time. So displacement is over time. So if we want to find velocity, displacement over time. Let's say we wanted to find the displacement of an object. So if we know the velocity and we know that the time, we could find displacement by multiplying velocity times time. Let's say we knew the displacement and we knew the velocity, and we wanted to figure out how long the object's been traveling. Then we could just do the inverse over here. So we can say time equals displacement over velocity. Displacement over velocity equals time. We'll do a little bit more about proofs of these formulas, but for right now we can keep these in mind as we move forward. So, just a couple quick things here. Now you can also represent pretty much everything in terms of velocity, acceleration, displacement. You can use it graphically. So a few things to recognize as we are moving forward. On a position versus time graph, so a graph that is position or displacement over time, the slope of this graph, the slope of a position time graph, represents the velocity of an object. And again, we know slope is rise over run, so if it's displacement over time, Well, we already mentioned displacement over time is velocity. Now, in a velocity time graph, or a velocity versus time graph, the slope of this velocity time graph, so again, it's a graph that is similar, we have time, and then the dependent variable is velocity. And if it's in uniform motion, so the slope of this velocity time graph, if it is changing, if the velocity is changing, we can use the slope of this velocity time graph to represent the acceleration of an object. So the slope of a velocity time graph can represent the acceleration of an object. Now, in the same velocity time graph, the area under a velocity time graph can be used to represent the displacement of an object. So whether it's a situation where the velocity is changing or it's accelerating, like this area here can represent displacement. Or in the case of v over t, constant velocity, so if the velocity is staying the same, then this area right here underneath the arrow of a velocity time graph, this area represents displacement. And again, if you think of a rectangle, the area of a rectangle is the length times the width, and in this case it's the velocity times the amount of time that's been passed. So displacement is v times t, which we kind of mentioned before. Displacement equals v times t.